Okay, this is still 7.3. So this is example 4. This is going to be an infinite solution system, which I'm warning you about ahead of time, but the way I started is the same way. I am going to label them again, that's just so it's easier for me to refer to the equations. Okay, I want to cancel one of the variables. What do I see? I see the x's in a and b are going to cancel easily, so I'm going to go ahead and do those first. A, B. Okay, now I need to cancel the x's again, but I have to use equation C this time. So let me look at equation C. This is a 2x. I think I'll use equation A with 2x. I can multiply A by -2, and that should cancel it. So equation C, and then I'm going to multiply equation A by -2 to cancel the x's. I could have used equation B too. -2x, +2y, -4z equals -10. Okay, and I'm trying to cancel out the x's again. Okay, let me go ahead and line up my equations, my yz equations. Okay, so that can't 0 equals 0, which is a true statement, which does tell me that this is going to be infinite solutions. And you need to write that 0 equals 0 because that's how we know to go down this line of infinite solution nonsense. So this is infinite solutions, but we are going to use parameter A to give a more specific description of what the infinite solutions are. Okay, so let me look. Okay, I'm going to let either x, y, or z equal to a. Okay, since these equations have y and z in it, I'm either going to pick y or z to represent my a. It does not matter which one. Your answer might look different than someone else's, but they're going to be equivalent answers. There's no wrong way to do it, but sometimes there's a slightly easier way to do it. Okay, so I think I'm actually going to let y equal a. And the reason is because later I'm going to have to solve for z, and z looks easier to solve for. Okay. You do not have to let y equal a. I could have also let z equal a. Okay, whichever one you choose to equal a, you need to write I let y equal to a, or I let z equal to a. Okay, I'm going to go ahead and plug that y equals a into one of those equations. So 2a plus z equals 3, and then I'm going to solve for z. So now z equals 3 minus 2a. So I have z in terms of a, which is good. I have y, I have z. Now I need x. Okay, to get x, I need to use one of the original equations. Which one? I think I'll use equation A just because it looks a little easier. I'm trying to solve for x. So I'm going to plug in for y and z. So I have x minus, for y, remember I let y equal to a, plus 2 times z. And for z, I found that to be 3 minus 2a equals 5. And that's because I plugged into equation A. So x minus a plus 6. Watch out, because my A's turn into 9s very easily. Okay, let me see. See, I'm going to get everything to the right side. So I'm going to, what is that, minus 5a, so I'll add 5a. Minus the 6, I get minus 1. Is that right? I think that's right. Okay, so now I'm going to express my answer as an ordered triple in terms of a. So for x, I got 5a minus 1. For y, I let that equal to a, and for z, I let it equal, I found 3 minus 2a. And remember, depending on what you chose to be A initially, you might have a different ordered triple, but they are actually equivalent if I plugged in the same value. If I wanted to check, I could take these three and plug them into each of these equations and make sure they equal what they're supposed to equal to. Okay, for example 5, this is what they call a non-square system. Why is it not non-square? Because it kind of looks like a rectangle where the variables are. Normally, if we have three variables, we have three equations, which makes it look kind of like a square on the variable side of the equation. Since this is a non-square, meaning there's fewer equations than its variables, this is most likely to be a dependent system, although occasionally it could be a no solution system. But there's not going to be an ordered pair, an easy ordered pair for this. Okay, so I'm going to go ahead and try to cancel something. The y's cancel, the y's almost cancel. This is a typo. Make that a plus. I was trying to make the y's cancel so it's easier. I'll change it on the blank notes. Okay, now the y's cancel. So I get 2x, the y's cancel, minus z equals 5. Okay, I don't have a third equation, so that's the best I can do. So I am going to use A to figure out this situation. Okay, and this is an infinite solution system. If I actually graphed it, the intersection would probably be a line because these represent two planes. Okay, now I need to figure out if I want to let x equal a or z equal a, and I'm saying x or z because in this equation I only have an x or a z. Okay, whichever one's easier to solve for, I'm going to plug in for the other one. So z looks easier to solve for, so I'm going to let x equal a. You don't have to do it the way I do it. You just have to tell me which one you pick, though. Okay, so 2a minus z equals 5. So I'm going to get z equals, and I'll minus the 5 over, 2a minus 5. So I have x equals a, z equals 2a minus 5, and then to get y, I'm going to go back to the original equations. I'll just use the first one. 4x, x is a, plus 2y minus 3 times z. I'm going to simplify this before I move it to the other side, so I'm a little less likely to make a mistake. So I'm going to get y equals 2y equals 2a minus 16, and I'll divide by 2, so I get y equals a minus 8. If you get fractions, don't panic. It's very common to get fractions on these. I try to pick the variable to represent a to make it easier, but it does not always work out. Okay, and so there are infinite solutions, but I can represent that by this ordered triple, and I could plug in any real number for a, and it would give me some ordered pair that lies on the line that where these two planes intersect. Okay, one last example for section 7.3. You commonly use three variable systems to find the equation of a parabola when they give you 3 points, and none of those points are a vertex. If it were a vertex, I would use standard or vertex form, and this would be pretty easy. Okay, they did give me the general equation for a parabola, which is this. So I'm going to start out knowing that this is my goal, and this is what I'm going to plug into. They gave me 3 ordered pairs. This is the x, this is the y. I'm going to go ahead and plug in the first equation, the first x and y values into this general equation. So negative 4 equals a times x squared. Okay, I'm going to simplify it a little bit to the right. And when you get used to these, you will skip to the simplified step. Okay, let's see. If I do negative 1 squared, I get positive 1. So this is really saying 1a minus 1b plus c equals negative 4. Okay, and I am okay with you skipping to here. It won't make sense yet, but once you've done a couple of them, it will. Okay, I'm going to go ahead and plug in the next ordered pair. Okay, so y equals a times x squared plus bx plus c. Okay, and I am going to rewrite it just because I'm going to have to solve it. So 3 squared is 9, so 9a plus 3b plus c equals negative 8. Okay, since I need to find A, B, and C, I do need 3 equations. So let me go ahead and plug in the last ordered pair. This is x, this is y, and I'm plugging it in that a general equation y equals ax squared plus bx plus c. So y equals a times x squared plus b times x plus c, which I'm going to rewrite simplified as 2 squared 4a plus 2b plus c equals -1. So these are my 3 equations. I need to solve for a, b, and c. The nice thing about these is that c normally cancels. No, c always cancels very easily. Should I show you the shortcut? I'm going to show you the shortcut, although if you look at the notes posted, I didn't do the shortcut. Okay, now the shortcut is the fact, I use the fact that the c always cancels easily. Okay, so if I look at the first 2 equations, I hope this doesn't freak you guys out. Okay, I want to cancel the c. I could just subtract the equations and cancel the c. Okay, if I subtract these equations, 1a minus 9a gives me -8a. -1 minus 3 is going to give me -4b. No, not, well, yeah, it is equals, I skipped. C minus c cancels, equals -4 minus -8 is -4 plus 8, which is going to go to a 4. Okay, now I'm gonna use the second 2 equations, and I'm just gonna subtract because the c's are gonna cancel. So if I do 9a minus 4a, that goes down to 5a. 3b minus 2b goes down to b. C minus c cancels, equals -8 minus -1 is -8 plus 1, which is -7. Okay, if my skipping, doing that subtraction of my step really bothers you, I could also just rewrite this equation, multiply this by -1, and I will get this result. I could rewrite this one, multiply this by -1, and I would get that result. But these have a lot of steps, so I'm going to go ahead and try to make my life easier. Okay, let me see. Let me rewrite these equations over here. So -8a minus 4b equals 4. 5a plus b equals -7. Okay, I could use substitution on this. I'm going to go ahead and cancel the b's. And rather than make the equations get bigger, I think I'm going to make them smaller because I can tell on the first equation I could divide everything by 4. So I'm going to go ahead and divide everything by 4. That's going to give me -2a minus b equals 1. And then if I keep the second equation the same, the b's are going to cancel. I didn't have to do it that way. I could have multiplied the second equation by 4, but in the interest of keeping the numbers smaller and because I just happened to notice that they were all divisible by 4, I did it that way. Okay, so I'm going to get 3a equals -6, a equals -2. Okay, what do I need now? Now I need b. I'll go ahead and plug that back into one of the equations. Which one? I'm going to plug it into the 5a plus b equals 7. So 5a plus b equals -7, -10 plus b equals -7. B is 3. I still need c, and then I also need to go back and write my equation. I'm going to use my blue equation. So a minus b plus c equals -4. Okay, I got c equals 1, which is great, except for I'm actually trying to write an equation. I'm not just trying to solve for a, b, and c, even though that was the hardest part of the whole situation. Okay, so now I need to actually write the equation. The equation is y equals a x squared plus bx plus c. So y equals -2x squared plus 3x plus 1. If you wanted to check your answer, if you plugged in the original 3 ordered pairs, they should check in this equation.